All right, today we're going to talk about our real world functions. So we're going to be looking at graphs and interpreting different information based off of that graph. So first off, you always read a graph from left to right. So you're always going left to right when you're reading the graph. So a graph is increasing if the x values increase and the y values increase. A graph is decreasing if the x values increase but the y values decreased. And a graph is constant if the values increase but the y's do not change. So again, we're going to read this going left to right. So this is an example. And now let's go down here, to this part, and we'll kind of talk a little bit more about the graph above. So if you're going from left to right, you'll notice first you're decreasing, it's constant, then it's increasing, it's constant, and then it's decreasing, and then constant. So we're going to look at this graph. Now we're going to break it up into each interval. Every time there's a change in slope or a change in the direction. So if you notice here, we're going up and then it stops. So where this point is, we're going to draw a line, and this is going to be our first interval because, again, remember, we're going left to right. Then we go from here to here, and since we've got another change here, this is going to be our second interval. And then from here to here is a different change, so this is going to be our third interval. And then we're going to look up here, and it changes to here, so this is our fourth interval. And then after, we've got another change, so this is our fifth interval. So now let's look at each interval. So as we said before, this is increasing because as we go from left to right, this is going uphill, so this is positive, and it's linear because it's a straight line. Interval 2 is decreasing because we're going downhill, it's a negative, and then it's also linear because it's a straight line. Now, if you notice, interval 3 is constant because it's a horizontal line, your y's are not changing. But it is linear because it's a straight line. Now notice for interval 4, it curves. And since it curves, it's non-linear, but it is going up, which makes it increasing. And then lastly, at interval 5, it's decreasing, and it is a straight line, so it's linear. So the biggest thing is just to make your intervals every time there's a change in direction, change in slope, and that's where you get that, and then you're able to determine what it is. All right, so let's look here. Now again, I'm going to look going left to right, and every time I have a change, I'm drawing an interval. And notice we're a slight change here, so we're going to go there, and we're going here. And then last we have that. So let's look here. At interval 1, it's constant because it's horizontal. Now we're going to write this interval using an inequality. So we're only looking at our x values. So we're looking from 0 to 2. Is your first interval. And then now we're going to increase, and that goes from 2 to 4. So this interval goes from 2 to 4. So you would write it as 2 is less than x, which is less than 4. Now we're not going to say it's equal to because it's not stopping on a point, it's continuing on. All right, and then for 3, it's this part right here, and this is from 4 to 5 on your x-axis. So that's why we put 4 is less than x, which is less than 5, and it's decreasing. And then we're going to continue to decrease, but it's a change in the slope or change in direction. So this is from 5 to 7. And then from 7 to 9, it's increasing. And that is 7 is less than x, which is less than 9. And then lastly, we have another change in the slope. And then this is from 9 to 12. So that's why we wrote all of that. All right, so remember, every time you have a change, make an interval and then describe the interval. All right, I want you to go ahead and I want you to try this one. And then now we're going to talk about some more vocabulary. So for this one, the dependent variable goes on the y-axis, and it's called the dependent variable because its value depends on the x value. So just be careful how it's measured. So this is your dependent, and then your independent goes on the x-axis, so this is the x-axis. If time is one of the variables, it's always independent variable. And then again, just watch how you're counting by it. All right, so next up, we're just going to look at some situations and determine if it's the independent or dependent variable. So remember, independent would be your x value, and the dependent would be your y value. So the temperature of a carton of milk and the length of time it's been out of the refrigerator. Well, the longer as the time increases, doesn't that mean the temperature is also going to increase? So for these, this depends on that. So this is independent and this is dependent. Now, the weight suspended from a rubber band and the length of the rubber band. Well, the heavier it is, the longer it's going to be. So the length depends on the weight. So this is independent, and this is dependent. All right, so the length depends on the weight. And then for here, the diameter of the pizza and the cost. Well, the bigger the pizza, the more it's going to cost. So the cost depends on how big the pizza is. So cost is dependent and diameter is independent. And for this one, it says the amount of time you study for the test and the grade you get on it. So your grade depends on how long you study, hopefully. So this would be considered the dependent, and this is the independent. And then lastly, number of cars on the freeway and the level of exhaust fumes in the air. So it'll be a lot of pollution, a lot of exhaust. This will depend on how many cars are on the freeway. So this is dependent and this is independent. So just reading the situation, just thinking about what depends on the other thing, and that's how you can determine which one is independent and which one's dependent. All right, so now we're going to go through this, and it says the function f of x is equal to negative 0.25 or 2500ths x plus 5 models the height of a candle x seconds after it is lit. So x is seconds. What is the meaning of the y-intercept? So y-intercept is always going to be the constant in a linear equation, and that's your beginning, your initial, your service fee, your service charge. So in this case, it's going to be where the candle height begins. It can't be the final height because this would just be what y is after, but not the y-intercept. The rate is your slope, and this would be, and then the amount of time it takes for the candle to burn, that's your x-intercept. So the best choice for this one would be A. All right, now on this, we've already talked about this before with one of our lessons, but if f is a function, if 9 equals f of negative 2, we know x is negative 2 and y is 9. So same thing here. If 2 equals f of 10, I know this is my x, and I know this is the result or the output, which would be my y. So independent, dependent. All right, so now let's look here. We're going to determine, let f of t be the number of people in millions who own an iPhone after the year 2007. Explain the meaning of the following statements. So when you're looking at this, 0 is 2007 because that's when you're beginning. And then we want to know in 2007, that means f of t, so this is your y, is a number of people. So in 2007, 2 million people owned iPhones. Now in this one, it says f of 5. So remember, if 2007 equals 0, if we were to add 5 years, we're going to end at 2012. And then if f of 7, so you're going to take 2007, which is 0, and add 7 to it, and you'll get 2014. And we know this is going to be less than that. So if we put that in words, in 2012, less people had iPhones than 2014. All right, and then here, f of 10, again, this is 0, so we're going to add 10 to that, and we'll end at 2017. We know it's going to be 217 million people. So now let's put it all together. In 2017, 217 million people owned, did I forget an N? I did. Owned iPhones, period. All right, so now what you're going to do is you're going to look at this graph, and then it wants to know which situation is represented by the graph. And remember, you're going to read it going left to right. So which answer you're going to answer matches this graph. So go ahead, complete this one. And then for this last one, it says 3 runners ran a 100-meter race. So we want to know which runner won the race. So look at your X values. Look at what's happening with your Y value. Which runner stopped for a rest? So here's a hint. If you stop, your speed will be constant. Which means a horizontal line. So in this case, I'm just going to put horizontal over here. Remember, horizontal goes that direction. So you're going to answer this question of who stopped, and then how long was the stop. So again, you're going to look to see how many seconds, and then how long did Bob take to complete the race. So you're going to find Bob up here, and you're going to look to see he took 14 seconds to finish. And then it says to calculate Albert's average speed. So figure the distance and time first, and then once you get that, then you're able to figure out his average speed. So we'll go over those as needed, but I want you to try these last two on your own using the information from the graph. So the biggest thing here in your real world functions is read the graph left to right, and then make sure you understand how to create the intervals, and then you have your independent and dependent variables.